Hello everybody. Today what we're going to be looking at is lesson 3.6. So go ahead and work through 3.6 with me. Now this is a little different. I'm going to do a few of these example problems and then I want you to work together either by yourself or with your partner. After that, also double check the link of what we are going to be doing next. So you're going to have to complete all of these and I'm going to complete most of them, but you're going to try a few on your own, okay? So it says, in each of the problems below, I shared some of the information that I know about the sequence. Your job is to find a minimum of 4 of the following things for each sequence. That could be a table, a graph, an explicit or recursive, a constant ratio, or a constant difference between the consecutive terms. Are there any terms that are missing, the type of sequence, and a story? That's a lot of information, so you guys can choose what you want to do here. So what I'm going to do is I'm going to start off by making a table here. So they're giving me recursive, and they're telling me that 1 is negative 12. And it's telling me then to get to the next term, I just add 4. So let's go and make a quick table. We'll do like 4 or 5 values. So 2, 3, 4, 5. And all I'm doing is adding 4. So negative 8, negative 4, 0, and 4. Perfect. And then we're done. So that's the first one. Next thing, it says it wants to know, well, let's go and give an explicit equation. So the explicit equation here would be y equals, or f of n equals, and then I have a slope of 4, and I know when I plugged in 1, I got an answer of negative 12. You can write it like this, or you can simplify it a step further to get y equals 4x minus 4 minus 12 would be negative 16. So there's a second thing. So I just give you a table. Let's see, an explicit, which I just did, a recursive. So the next thing now is constant ratio or constant difference. And the constant difference, I'm just going to put CD, is equal to positive 4. It's basically just the slope here. Constant in consecutive terms, and any terms that are missing, the type of sequence. All right, and so then this is an arithmetic. Like I said, there's multiple things you could have done. You could have drawn a graph here, and let's see. My y-intercept would have been all the way down here at 0, negative 16, and we just had a slope of going like up 4 over 1. Okay, just like a nice little rough sketch. So yeah. So I know that the first 5 terms of the sequence are 0, negative 6, negative 12, negative 18, negative 24. So what do we know? Well, I know I'm going down by negative 6 each time. So the first thing that I can do is, let's see. Let's just say this is, I know that the first 5 terms. So when I hear first 5, it doesn't always mean this way, but it means that f of 1 equals 0, or it also means f of 0 equals 0. Either one is acceptable. So let's go ahead and start with the recursive. I'm just going to start with f of 1. So to get to my current term, what I'm going to do is look at my previous term. I'm just going to be minus sin 6. And I'm going to start at my first term is 0. From there, I can write my explicit. Explicit is just f of x is equal to, I'm going down by 6. I'm going to have x minus 1 is equal to 0. Or you can have f of x equals negative 6x plus 6. So that's 2 things. Let's see, the next thing what we could do is we could have drawn a graph here. So we can start at positive 6. Now we're just going down 6 each term. Let's see, and this is also an arithmetic. Alright, so next one, guys, I'm going to start jumping around. Well, I'm going to jump around and give you a few examples. Every one that I do not do, I would like you to go back and fix, okay? So I am giving the explicit, and I have an n with no n minus 1. So if I were to look at the recursive, it's saying to get to my current term, I look at my previous term, And what I'm going to do is just multiply it by 3. And then I know f of 0, not f of 1, but f of 0 equals negative 10. And I know that because its n is just like that. So now what I'm going to do is just make maybe like a table of n and f of n. And I know 0 equaled negative 10. And then when I plugged in 1, this would give me negative 30. 2 would give me negative 90. 3 would give me negative 270. So I'm basically tripling from the previous term. Okay, let's see. Next thing here is we know that this is geometric. So that's 1, 2, 3, and one more thing here. Let's see, what am I missing? Table, graph, explicit, recursive, constant ratio, and constant difference. My constant difference, guys, equals negative 3, which, is positive 3. All right, now how do you find a constant difference just given a list of terms? Well, what we're going to do is you just take the second number and divide it by the first and any two consecutive values. So we have 4.5 over 3, 6.75 over 4.5. All of these reduce to the same exact number, which is 1.5, or 3 over 2. Either one that works for me. So that's my common ratio. From there, we can say the recursive form is to get to my current term, I look to the previous term. I'm going to multiply it by 3 over 2. Once again, you get to decide, is that 2 f of 1 or f of 0? I'm going to say f of 0, f of 1 or f of 0. I'm going to say f of 0 just because we did f of 1 up on the previous one. I can show you how that changes things. So f of 0 equals 2. Okay? So I know my common ratio. I know my recursive. Let's see. Let's go ahead and look at the explicit. So the explicit is, we're going to start off with our value of 2, and we're going to multiply it by 1.5. And now we need to decide, is it going to the x power or the x minus 1? In this instance, it's x because we said that f of 0 equals 2. If you were to put f of 1 equals 2, that's no problem. Just make sure you have a minus 1 there. So let's see, common ratio, recursive, explicit, and this is also a geometric. All right. So now, guys, what we're going to be doing is looking for a geometric, based off this information. A of 3 equals 10 and A of 7 equals 26. This kind of goes back to showing you like the tables. If you remember, we're just going to have part of the tables here. So this is my third, and we have fourth, fifth, sixth. So let's see, 4th, 5th, 6th, and then 7th. With the values of 10 and 26. And two ways to do this. I'm showing this visual, and I'll just show you how to do this. So I'm going to use the difference 1, 2, 3, 4 times. And if you notice that, it's like, oh, if I'm at A3 and A7, only 7 minus 3 is 4. So if I do 7 minus 3 equals 4, that's how many times I use the difference. I used it 1, 2, 3, 4 times. So I know I used the difference 4 times. And what was my change when I used the difference from 4 times? Well, it was from 10 to 26. So that means that that was that is 16. So that means when I divide both sides by 4, the common difference is 4. All right, so now I have my common difference. So now we can do a few things here. You can plug this into point slope form to get the explicit. So in different colors, because I kind of ran out of room pretty quickly there. Let's do the recursive first. It's telling me to start off at f of 3. That's the only piece of information they're telling me. So we can say f of 3 is equal to 10. And I know to get to my next term, I look at my previous term, I'm adding 4 to it. So that's recursive. Let's see. It tells me it's arithmetic. So I'm going to fill out this table, and that will be my next thing. So if I start at 10, and this is term 4, 5, and 6, I'm just adding 14 to 14 to 18 to 22, so on and so forth. So we have a table now. Next, we can use explicit. So we'd have f of x equals our slope of 4, and instead of 4x, I'm going to do x minus, it's not 1 because I don't have the 1 value. It's going to be x minus 3. And then I'm going to have a plus 10 here. If you were to simplify this, this would be f of x is equal to 4x minus 12 plus 10 to get a final one of 4x minus 2. Okay? All right, so we have recursive, explicit, table, common difference is 4. So it's my 4 values. All right. So it says, I know that the sequence is modeled by the perimeter of the following. So let's just say each one of these is 1 unit. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So right here I have 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so let's count one more and then we'll figure this out. So 1, 2, 3, 4, 5. Excuse me, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we have 5 and 5, and all of these would be 4. So let's look at the total perimeter. I have 6, 14, and then 10 to 22. And you can see, oh, well, I add from 6 to 14. That adds 8. And 8 to 14 to 22, I'm also adding 8. So that means I know that this is a common difference, and that equals 8. If I want table values of x and y, or x of f of x, on figure 1, 2, 3, 4, I'm just adding 8 each time. So this would be 6, 14, 22, 30. Okay? So from there then, I also can come up with the explicit and recursive. Let's start with recursive. F of x equals f of x minus 1, and I'm adding 8 each time. I know on f of 1, this equaled 6. Then also on explicit, we have f of x is equal to 8 parentheses x minus 1 plus 6, or f of x equals 8x minus 2. Okay. So 1, 2, 3. We got all 4. Okay, so let's see. From here, guys, I'll go over a summation one, and then I would like you guys to try some of the others. So it says, I know the sum of the sequence represents this. So it's not asking you to actually find anything, but what do I know? Okay, well, I have an n minus 1. I have a common ratio of 1/2. I know my initial value is 16. Okay, so we can write a lot of this stuff here. So right here, I have f of x. So this is recursive. To get to my current term, I'm going to look at my previous term, and I'm going to multiply it by 1/2. I also know that my first term, and I know that because the n minus 1, I also know it because this n equals 1, and I also know that's going to equal 16, because that's my start value right there. So that's two things. I know that this is a geometric model, and I know that my common ratio is 1/2. Okay? All right, so there's a handful more of these that I would like you to try on your own. So I did the first 7. At this point, I would like you to do 8, 9, 10, 11, and 12. Okay? If you have any specific questions on these, please let me know, and I will be more than happy to answer your question. Please send it via email, okay? At this time, when you're done with 8 through 12, I would like you to go ahead and start your homework, which is RSG 3.6. All right, guys, see you later.